Hi everyone. In this video we are going to see about evaluation metrics used in binary classification. So, the first step is to create a matrix of number of correct and incorrect predictions for each class label. Here we can see the confusion matrix which provides the prediction total for various y and y hat values. The diagonal line represents the correct predictions and the color intensity is used to indicate the number of predictions in each cell. Now, coming to the accuracy, it is the proportion of predictions that the model actually got right. So, in mathematical terms, it is given below. Now, when we apply the values from the matrix, we get 0.83. That is 83% of the time the model produced results are correct. It is not actually a good metric to evaluate since it does not evaluate based on features. Now, coming to the recall, it is the proportion of positive cases correctly identified by the model. So now when we apply values from the matrix, we get the result as 0.75. That is 75% of the patients have diabetes. Coming to the precision, it is the proportion of predicted positive cases where the label is actually positive. Now, when we apply values from the matrix, we get the result as 1.0, that is 100% of the patients predicted have diabetes. Now, coming to the F1 score, it is the combination of recall and precision. Now, when we apply the values from the matrix, we get the result to be 0.86. Now, coming to the AUC or area under the curve. Here, talk about two important metrics, that is true positive rate, also known as recall, and false positive rate, which is FPR. These two are used to evaluate the model, which plots the curve known as the ROC curve, received operator characteristic curve, which compares the TPR and FPR for all the values between 0 and 1. Now, for a perfect model, from the figure we can see that it goes straight up the TPR axis on the left and then across the FPR on the top. This produces perfect curve would be 1.0, which is correct 100% of the time. Now, when we draw a diagonal line from the bottom left to the top right, it could be correct 50% of the time. Now, in our diabetes model, area under the curve metric is 0.875, which is higher than zero point 0.5. So, the model performs better at predicting rather than randomly guessing. Thank you.